weightlifter is adding plates of equal weight to a bar. The table below shows the total weight, including the bar, that he will lift depending on the total number of plates on the bar. Based on this information, which statement is true? Okay, so we have some information here. What we don't have is an equation. So is there a way we can come up with an equation given this chart? Yeah, what do we put it in? Very good. So that's exactly what I'm going to do. I'm going to take this, put it in that stat in our calculator. Remember, this will be my list 1, this will be my list 2, because these are my x's and these are my y's. So in my calculator, I press stat, edit. In list 1, we're going to put the first column, so that was 2, 4, 6, and 8. And in that second column, we're going to put the weights. So 115 and 185 and 255 and 325. Okay, and once we have those saved, we press stat again, go over to calc, choose number 4, calculate. And there's our equation. Okay, so we have that the equation of this graph is y is equal to 35x plus 45, right? Okay, does the 35 or the 45 tell us when we would start graphing this? The 45. Okay, so this is my starting point. This is how much that we start with when we are at x is 0. So when this reads 0, there's still a 45 in that other column, okay? So which one of these answer choices says that? C, right, or H, yep. Good job. Okay, so now that we've kind of refreshed ourselves on how to use stat, let's look at this first example. It says that scientists studied the weights of 2 alligators over a period of 12 months. They want us to use these tables to determine the initial weight and the rate of growth for alligator 1 and alligator 2. After how many months did the alligators weigh the same? So if we look at the chart, there's no time where they're weighing the same, right? So we're going to need to go further than what the charts tell us. So just like in our warm-up, we're going to need to put these into stat so we can come up with an equation for them, right? So I go back to my calculator, stat, edit. We're going to do alligator 1 first. So for alligator 1, we have the months 0, 1, 2, and 3. And for the weights of alligator 1, we have 4, 5.5, 7, and 8.5. Okay, so stat, calc 4, and what is that equation telling us that we should have for alligator 1? Very good. So we have y is equal to, he converted that to 3 halves, x plus 4. Good job. All right, now we need to do the exact same thing for alligator 2. So I go back to stat, and I need to change out the weights for alligator 2. So the weight for alligator 2 is 6, 7, 8, and 9. And what's the equation for alligator 2 going to be?
1x plus 6.
Very good. So we have y is equal to 1x plus 6. Okay, so we are going to use these equations and see where they cross, just like what we did yesterday. Okay, so for alligator 1, where am I going to start my graph at? 4. So I come over here, give myself a point at 4, and where am I going to move to put the next point?
Okay, the next one.
Good. here is alligator 1. All right, for alligator 2, where are we going to start our graph at? Good. And that slope tells us to move where? Good. All right, so did these two lines end up crossing?
Yes.
Yes, right here at this point, right? Where is that point at?
And 4.
Other way around, right? 410. Good. All right, so our solution is 410. So the question that they asked us here was, after how many months did the alligators weigh the same? Well, the first column represents my x's, right? And what did they call the column right here? What did they call the first column? Months. Okay, so months are my x's. They want to know after how many months did it work out. So 4 months. Very good. 4 months until they weighed the same. Good job. Okay, so not only are you actually able to use your calculator to come up with the equations like we did here, there's actually a way to find this intersection point right here in the calculator without us having to graph it on the paper by hand. So that's what we're going to do next. Let the calculator find that point for us. So it says these are the equations, or the steps. You always want to make sure you're in y equals mx plus b, just like normal. But instead of going and graphing them on your paper, you're going to put them in y1 and y2 in your calculator. And then you'll just press second trace, choose number 5, and press enter 3 times. And it's going to tell you where that coordinate point is. Okay? All right, so let's give that a try. Flip it over onto the back. So we need 2 equations. The first equation, is it in y equals mx plus b form right now? No. So what do I need to move? Right. So we subtract 4x from both sides. And now I have y is equal to, we can't combine the 4x and the 3, right? So we leave them separate. And now is it ready to go? Okay. And then for the second one, they didn't even give us an equation, they just gave us a table. But can we turn the table into an equation? Yeah, so we're just going to go to stat in our calculator and put those in our lists. So we got -4, -1, 0, and 2 in list 1. And in list 2, we've got -16, -7, -4, and 2. All right, so what did our equation for that one end up being?
Y equals 3x minus 4.
Nice. Okay, so we have y equals 3x minus 4. Okay, so now instead of us graphing it, which is going to be pretty hard if there's no boxes, right? We're going to let the calculator do the work for us. So remember, on the front page, they said the first step is make sure they're in y equals mx plus b. We have that now, right? Okay, step 2. You go to the y equals button, and you're going to type that first equation in y1. So our first equation ended up being y is equal to -4x plus 3. And then in y2, you're going to type our second equation, which was 3x minus 4. Okay? Once you have those 2 equations typed in to y1 and y2, you're then just going to hit graph, and you should be able to see where your lines cross. So we can see where they're at, right? We can tell that it's at a positive x value but a negative y value, so we know what to expect for our answer. Okay, to get the calculator to find that point for you, you press second, this button right here, trace, the 4th button on that top row. Oops. And then choose number 5, the one where it says intersect. We're looking for the intersection. And then you press enter 3 times. And where does it say the intersection point is at? What did it tell you at the bottom of your screen? 1, -1, right? So my intersection is going to be at 1, -1. Now they do want us to give a sketch over here. So we know that that first equation started at +3, right? So I'm going to put a point there, and it had a negative slope. So we know it's going to slant this direction. And then this one started at -4. I'm going to put a point there, and it had a positive slope. So it slants the other direction. So whenever I draw those in, they end up crossing right about here, which is at a +1, -1. Okay, let's try doing that again. So on number 3, is that first equation ready to go right now? Okay, so we've got x minus 3y equals 6. How are we going to fix it?
Take away
Good. So we've got -3y is equal to -x plus 6, right? Okay, then what should we do? And how are we going to do that? Good. Divide everything by that -3. Alright. What's that secret number in front of x? 1. So I've got -1 divided by -3. I can't actually divide those, but we do know 2 negatives is going to give us a right. So we've got, very good, and 6 divided by -3, very good. Okay, so there's our first equation. That's my y1, 1/3 x minus 2. Okay, now we need to fix that second equation as well. So we've got 2x minus 6y equals -6. How do we fix that one? Right, we're going to move that 2x. Good. So we got -6y is equal to, we can't put them together, so just -2x minus 6. Then what should we do? Good, divide everything by that -6. Alright. So I've got -2 divided by -6. What is that going to simplify to? 1/3, right? 2 negatives make it that positive 1/3x. And what's -6 divided by -6? 2 negatives make it a positive 1. Good. So I've got 1/3 x plus 1. Alright, so if you want to see what a sketch of that would look like, we go to y equals, type that first equation in y1. So I've got 1/3 x minus 2. And then we would have in y2, 1/3 x plus 1. Once we have them typed in, we hit graph. And what do we see there on our graph? They're parallel, right? So are they ever going to intersect? So what's our answer if they never intersect? No solution. Very good. My answer here ends up being no solution. And you can draw a little sketch of what you think those would look like. This one starts at, where is that? -2. Give yourself a point at -2, one at +1, and then they should have the same slope. So like something like that. Oops. Picture. All right. Okay, we got one more to look at here. They want us to come up with the equation. So, over here in the picture, they drew some coordinate points, right? Okay, so let's see here. I'm going to write down my coordinates. So this one will be for line AB. So that's this one down here. Where is point A?
708.
This point right here. Negative. -6 gets me to here, and then I have to go down how many? How many? I don't think it's 5. 4. Okay, so this is the coordinate point, -6, -4. So I'm going to put that in my list over here. We got -6, -4. Okay, where is point B at?
-3.
So do we go left or right any? No, so it's 0, -3. Okay, so I'm going to add that to the list. Okay, so that's 2 coordinates. That's enough information for me to come up with the equation for AB. We also are going to need a list for that other one, DC. Okay, so this one's for DC. Where is that point D at? -4. -4 what? Good. So I'm going to put that in my table over here. And then we also need point C. Where is the coordinate point C? 0 what? 7. Good. Okay. All right. So now that I have these tables, we can put them in stat, and it'll tell us what our equations are. Okay. So I go to my stat. And I'm going to put in these values. So we're going to put in AB's first. So we'll have -6 and 0 for my x's. And then in list 2, we're going to have -4 and -3. So stat, calc 4. What's going to be the equation for line AB? All right. So we need to convert that to a fraction, right? So 1.66666 repeating converts to 1/6, right? So we got 1/6x minus 3. All right, now I need to go change out my points in stat again so I can find DC. So I go back and I'm going to change out those numbers. So now my x's are going to be -4 and 0. And then in list 2, we're going to have 9 and 7. And where is this one's equation, or what is this one's equation going to be? -1/2. Good. So we got -1/2 x plus 7. Right? Okay. So we have the 2 equations. Now I need to go into y equals and type my 2 equations in. So I'm going to have in y1, we've got 1/6 x minus 3. And in y2, we've got negative 1/2 x plus 7. I graph them. They are going to intersect, right? If you can't see it on here, you can always go to your window or hit zoom, either one. If you want your window, you want to see further on your x-axis, so I'm going to change my x max, make it a little bigger. And now I should be able to see where they end up crossing. Okay, so now that I can see where they cross, we press second, trace, and we want to see where they intersect. So we press number 5, and then you press enter 3 times. And where does it look like those intersect at? What does it tell us? 15, and right. Very good. 15 and negative 0.5 or negative 1/2. Very good. So, if you put them in y1 and y2, your calculator can tell you the coordinate point for you so that you don't have to try and continue your graph off the edge and figure out where they cross.